One of the reasons that I work with high-performance computing capabilities today is because the problems that we need to solve to understand how to manage our water resources actually exceed the human capability to reason about them without the aid of a computer.
High-performance computing today is probably more important to research than it's ever been in the past. So our mission here at the Texas Advanced Computing Center is to provide groundbreaking new computing capabilities to enable new kinds of scientific discoveries and new kinds of engineering research. Our next system, Frontera, will have a peak performance of around 40 petaflops, built around the next generation of Intel Xeon scalable processors to solve the very biggest sort of grand challenge projects in the scientific ecosystem. And then there's a few new instructions in there. The VNI instructions in particular have never existed in a previous Intel processor that make lower precision operations that have become very popular in areas like AI and deep learning. We will have far more processing capacity and far more memory capacity than we've ever had. I'm quite confident there'll be groundbreaking discoveries each year that we run the machine.
Systems like Frontera are going to open up new realms of possibility.
We think this machine, because it's based homogeneously around Xeons for its primary compute capability, and a programming model that we've been working on for many years and optimizing for many years, the first day we use it, it's going to be remarkably productive, and we think in terms of real science throughput, we'll get 3 or 4 times the performance that its predecessors will have. There's going to be a set of problems for which this is uniquely the fastest machine in the world. When we think about the Intel Optane DC persistent memory, it has several unique characteristics for us. It's like memory in terms of the form factor in which we install it, the way that we can address it from applications, but it survives a reboot or loss of power. So it gives us some new fault tolerance. It gives us enormous capacity. You can also look at it and actually use it as a storage device. And for a storage device, we're moving into the memory channels, so sort of a lot closer to the processor versus having something sitting on the far side of a PCI bus like a solid state drive or an NVMe device. So we have the opportunity for sort of higher bandwidth, locally addressable storage. So it has sort of unique aspects both as a storage device and as a memory device.
I think that high-performance computing is going to help us to move beyond the world that we've even imagined. So it's accelerating discoveries in fields that we would anticipate finding discoveries in, but more importantly, it's opening up and unlocking new areas of research that we've not even anticipated.